Hello everyone. I am Nitya, working as an assistant professor in EC department, R.M.K College of Engineering and Technology, and I'm handling control engineering. Today we are going to see fifth unit. Your fifth unit is state variable and state space modeling. In this we are going to see concept of controllability and observability. First we will concentrate on controllability. We will see what is controllability. Actually, the controllability verifies the usefulness of a state variable. In the controllability test, we can find whether the state variable can be controlled to achieve the desired output. The choice of the state variable is arbitrary while forming the state model. After determining the each state model, the controllability of the system variable is verified. If in case the state variable is not controllable, then we have to go for the another choice of the state variable. Actually, this is the definition of the controllability. A system is said to be completely controllable if it is possible to transfer the system state from initial state, that is x of t naught, to any other desired state x of td in a specific finite time by the control vector u of t. That is, when we have a system actually that we need to transfer some of the data. While we are transferring the data, we are considering it as an initial state. While we are transferring, we should get the data at the desired state with a finite time. So then we can call that system as a control system. So we can call it as a system is under controllable. Now we will see what is observability. In observability test, we can find whether the state variable is observable or measurable. The concept of observability is useful in solving the problem of reconstructing unmeasurable state variable from measurable one in a minimum possible length of time. In state feedback control, the estimation of the uncontrollable state variable is essential in order to construct the control signals. So this is the actual definition of the observability. A system is said to be observable if every state x of t can be completely identified by measurement of output y of t over finite interval of time. That is, while we are giving some input to the system and we are getting that output, in between we can able to read or measure the system, so that we can call it as an observability, so that we can call the system as a system is completely observable. So this should happen in a finite interval of time. Here we have two types of method to say whether the system is controllable and observable. The two methods, first method is Gilbert's method and another one is Kalman's method. Okay, now if we see for a Kalman's method, the calculation is very simple when compared to the Gilbert's method. Whereas in Kalman's method, the major disadvantages is that we can't able to predict in case if we are getting the system is uncontrollable or unobservable. We can't using a Kalman's method, we can't able to predict where the system, that is where the state variable is uncontrollable or unobservable. Whereas in Gilbert's method, we can say where the system is going to be uncontrollable. That is, we can able to predict the state variable where it went for uncontrollability or unobservability. So this is the major advantage and disadvantages of these two methods. So we will see, we will use these methods to solve the problem to predict the system whether it is uncontrollable or uncontrollable, observable or unobservable. Now we are going to see how to solve the problem for observability. So this is a problem statement. Consider the system with a state representation. Here they have given you the state variables and then the matrix with x plus the matrix with u. And also y is equal to the matrix with x1, x2 and x3. And the requirement is evaluate the observability of this system. So they have asked us to find the observability of the system. So we are going to follow the Kalman's test here. So the first step to solve this observability is step 1. We need to form the QO matrix.
Okay, whereas in controllability, we are going to form QC matrix. So here we are going to form a QO matrix. For this, we are going to have a formula called CT, that is C transpose and A transpose C transpose, and then A square, that is A transpose the whole square into C transpose, and it goes on up to A transpose n minus 1 into C transpose. This is the actual formula for finding your Q. To form your QO matrix, this is the actual formula. Or else we can write this as simply C AC A square C. It goes on up to A n minus 1 C. We can take the transpose commonly out. We can either follow this or we can follow this also. So first step, we need to form the QO matrix by using this statement. And then your second step, that is your second step is we need to find determinant of QO, that is QO matrix. Okay, also this should not be z equal to 0. We should have a non-zero value here in order to conclude system as a observability. So if we get a 0 value, we can say it as a system is a not observable. So in order to find this QO, we need to find where is CA. And in order to get all those things, we need to remember our state equation. That is, we already know x dot is equal to ax plus bu, and to find next is your y. So this is your cx plus du. So in order to find controllability, we have to compare this equation to find your a and b. In order to find your observability, we need to compare with this equation y is equal to cx plus du. While we need to compare this with your question to find what is c, what is d. So now we will compare this equation with y. Okay, now this is your y is equal to cx plus du. We don't have du, so we need to consider it as 0. So we got what is c here, and by comparing this equation with an x, so this is your a, x plus bu. So we have a here. So now we got what is c and what is a. This is your corresponding a and c from the question. So now what we need to do? We need to form the QO matrix by finding C, AC, and it goes on up to A n minus 1 C, the whole transpose. Now we need to find what is n here. So we already see in the previous video how to find n. So n is nothing but your order of the state variables. That is a number of state variables. So we have about 3 state variables here. So n is equal to 3. So the formula is a n minus 1. So 3 minus 1 will give you 2. So we need to find up to QO, C, AC, A square, C, the whole transpose. So after finding this QO, we need to take a determinant of this QO. Okay, this is how we need to proceed with the problem. Now we will see the solution for the problem. Actually, this is the Q naught. So this is actually what we need to find. C dot A, C dot A square, and the whole transpose. So now we find what is C. This is your C and this is your A. Initially, we need to find C dot A. Why? Because we have C already in the question. So we need to find C dot A now. So C dot A. This is actually the C value. This is actually the A value. So the first row with your first column will be filled out here. And your first row with your second column will be take place here. Your first row with your third column will takes place here. So now we got C dot A now. So next step is to find C dot A dot A. So we already have C dot A. Now the thing is to just multiply A along with the given the thing which we got in the previous step. So we got C dot A already. So just multiplying A with this. So we got the answer. So now we got all the three elements. So now we need to form QO matrix. So first is we need to fill out C, then your CA, and then CA the whole square. So we are taking the transpose also. So first thing is C. If it is in column, if it is in row, we need to take it as row. Sorry, if it is an row, we need to take it as an column. So first thing is here C. So 3, 4 and 1. Then is your CA. So now fill out with 0, 1 and 1. Now CA square 0, -2 and -2. This is the actual QO we got from this. Okay, now what we need to do? Now we need to find the determinant of QO. While finding the determinant of QO, unfortunately we got the answer as 0. So if it is a 0, then we can say it is an unobservable. So the system is completely unobservable. Also, we need to find the rank of the QO. Why? Because we need to check whether n should be equal to the rank of QO. So if we see n is nothing but we got as 3, we're going to have 3 state variables here. And if we find the rank of QO, we're going to have it as 2. So 2 is not is equal to 3. So we can say the system is completely, that is, system is not completely observable. So this is a step using a Kalman's method to find whether the system is observable or not.
Thank you for watching.